Cool. So our talk is Gitlab CI for dummies. The dummies part is basically because if you were at this, or I guess it's ELCE in 2019, Paul Barker gave a similar talk, and unfortunately, I was too stupid to understand it, so I had to redo all the work for myself. So I am a dummy. And those that don't know, X for Dummies is a popular book series in the US and probably all the English-speaking world. So a little bit about us. I'm John Mason. I work for ARM, who are very smart people, unlike me, who is a dummy. I am on the OpenEmbedded board, and I am co-maintainer of the Meta ARM layer. Bruce?
Oh, and that'll be me. Yeah, I'm Bruce. If you were here, you heard me prattle on about meta virtualization, but I am also claiming to be a dummy because multiple people have told me how to do this before, and I offered to work through it with John because it just won't sink in. But I work for Xilinx. I'm maintainer of the reference kernel, meta virtualization, and a few other odds and ends, and I am part of the OpenEmbedded TSC.
So we're not saying that you are a dummy or anyone else. We're not pointing any fingers. Just that I am personally a dummy. This took way longer than it should have, mostly because I am a dummy. Please learn from my mistakes so you can not be a dummy. And here's a little Red Fox, Sanford and Son reference if you're old enough to get that. And maybe only a few people are old enough to get that. So what is GitLab? Hopefully everyone here knows what GitLab is. It's not exactly new or anything super clever, but it is a web-based source code management similar to GitHub. And in fact, if you have a GitHub account, you can use it as a way to create a GitLab account. And as the name implies, it is Git source code oriented. So why GitLab? I guess first, it is my favorite price. It is free. And as free as in beer. It is open source, and it has robust features like wiki pages and CI/CD. So what is CI/CD, Bruce?
So yeah, I guess, you know, this really kind of depends on your point of view. Again, just like everything I do, apparently it all depends on your point of view to be the Star Wars reference. Depends on your point of view, whether I'm right or wrong. But you know, the big thing, it's CD that actually tends to be the area up for more debates. But in our case, it's continuous integration. It's the practice of taking all commits sort of, you know, as they arrive in either chunks or individually if you have a lot of horsepower, and merging them to some sort of shared mainline after they've passed some level of testing and sanity. Continuous delivery is, you know, where you want to make sure that the quality is always to the point where you could sort of release it at any time without having to go through a lot of extra manual steps. But of course, a lot of us aren't really doing either continuous delivery or continuous deployment from those CI, the CI part of the pipeline, but it's still a goal that we want to make sure the state of that branch is something that you could take your fork from and actually have a reasonable expectation of quality. All right. So the big thing is, and this is why I'm interested, is because I maintain a few layers that don't get a lot of patches, but it depends. They come in bursts. I'm always merging multiple different and sometimes complex kernel patches to the reference kernels, and the meta virtualization things can be all over the place. Different languages, different frameworks. So, you know, it depends. I can get up to, you know, wake up in the morning and I can have 30 different patches that I have to stare at and consider. And if they're simple, yeah, I've been at this for a long time. You can kind of look at them and you can rely on your intuition if it's going to break. But really, you know, before I send things to Richard for merging to OE core, I can queue up a run on the autobuilder. But really, even before I tie up those resources, I want to do my own individual sanity build testing on them. And for a lot of the kernel and meta virtualization, that's me with my integration, build checkout, and I probably have projects that have been build directories that have been around for some people have been working on OpenEmbedded in Yocto, because I don't like to delete old directories. I just keep reusing them and suffering the issues. But that's me building it, booting a QEMU, running some tests, and then deciding it's good enough, and then having somebody come along later and tell me that I forgot about user merge on Musel on PPC 32, and then we get a patch and we fix it. So my point is that I want to spend more time from my other presentation working on better open container image format hacking than building and booting and testing everybody's libvirt patches and K3S changes and things like that. So I mean, that's why it's useful, because I can't be an expert at everything. And unless you have a really rigid structure like the kernel workflow, you need to have some ability to sanitize those commits in chunks or in bit, and some infrastructure you can rely on, sort of, to free up your time to do interesting things.
So what are the drawbacks? So kind of to Bruce's point a second ago, if you had enough, if you had an infinite amount of computing resources, you can compile and test every single individual patch. You could pull out the ones that are breaking the build or breaking the test and do that, but it's not really feasible to do that, because each one of these runs can take hours, and I think hours is kind of an underestimation. Using this example that I just looked at last week of what was pulled into Pocky, there was 97 patches for that week. And if you compiled each one for each QEMU machine and it took only an hour, you would have over 1,000 hours. And that's almost, I think 6.5 times the amount of hours in that week. So yeah, it doesn't really scale very well. So Gitlab CI. So Gitlab CI is a tool that's built into GitLab for this exact reasoning. And again, it's my favorite price. It's free. But the caveat is, if you run everything on your own hardware, and I think Paul Barger touched on that a little bit in his talk. It doesn't even seem like 2 years ago, does it? There are alternatives to GitLab CI. GitHub has a workflow, which I believe Kim uses. Many companies are using a combination of Jenkins and Lava to test on actual hardware. There is actual ways to hook in Lava into GitLab CI, but I'm not touching that. And there are, of course, others. Okay, so who's currently using GitLab CI in the Yocto project world? We in Meta ARM are using it internally and for some version of external as we become external. Armin's using it in Meta Security. And then there's some work in progress stuff that I'm doing. I'm doing some kind of personally maintained patches for Meta Zephyr, which test it, and you'll see some pictures of that in the slides ahead. And then I tried to hack up something for Bruce to test the kernel, and it blew up spectacularly, and I ran out of time before this presentation. So yeah, here's kind of what a sample pipeline is, what they're called in GitLab. This is what it looks like. And what's really nice is if you look, I assume everyone can read this. It's big enough on my screen. You can see on the left under the status whether it passed, failed, or you can see this kind of orangey exclamation point, which means that it both passed and failed, which is a nice middle ground where if you know something is currently failing, but so you don't want it to blow up your current runs, like maybe you know that it's not working on PowerPC and it's an open bug, you'll get around to it eventually, you could mark it as okay to fail, and that way it won't flag you as failed and it'll actually pass. I'm splitting hairs here, but you can see you can actually run it on master, GatesGuard, Thunfeld. We're running all of these older branches as kind of a way to make sure that we're constantly up to date with the upstream. And here's what an individual one looks like that actually failed. And you can see inside it, there are actual individual tasks. This is actually all specific to your implementation. If you wanted to copy what we're doing in MetaArm, you can do it this way, or you can do your own things. But essentially, at the top, you have the actual entire patch. Well, the patch description, not the actual patch, but the patch description of what it's running against. And of course, the shot. I don't know if you can see my pointer or not. Probably not. And under build, you can see that course done 500, 700, etc. passed, but FVB base failed. So you can actually zoom in to see which ones are passing and which ones are failing. And let's do that, right? So here's I mean, unfortunately, you can see that these are, over 4,000 lines for a successful one, with an entry for everyone that's compiling. So it's hard for me to show you in a PowerPoint, but you can actually see that this one passed. There were no warnings or errors. We actually have a little mini script inside ours that that cause any warnings to actually be failures, because warnings are very often failures.
Yeah, I can see your pointer just fine.
Okay, cool.
Yeah.
Thank you. And then here's one that failed. So this, I'm not sure if anyone else noticed in the past week that master updated U-boot, which if you had something that was based on U-boot, caused your U-boot to break. If it wasn't upstreamed, which we tell everyone to upstream, and then they say yes and then don't do it. So then you get things like this, and then you tell them to rebase their patch, and maybe if you tell them enough, they actually do it. Hasn't been my experience, but I'm still hopeful, or naive, one of the two. But this tells you exactly what the error is, and you can kind of scroll up and see in a little more detail if you so choose. And this is Meta Zephyr. So what I'm trying to show here is not only can you have build, but you can actually have testing. And to show you a little bit more, this is running test image inside Zephyr, which it's pretty minuscule. And because it doesn't have any dependencies like test image does on Pocky for networking, it actually runs fine in a unprivileged container. But I'll get into that more in a second. But essentially, you can run tests in here is what I'm trying to show. So hopefully everyone's like, oh, this is super cool, and it looks super easy if this is for dummies. So how do I set this up? So you just need two things. You need a GitLab Runner and a GitLab Executor. And you might want more of those as well. So a GitLab Runner is I've stole this completely from the README, a lightweight, highly scalable agent that picks up CI jobs and through coordination of GitLab CI, runs the job and sends the result back to the GitLab instance. Yeah. And then you have the executor, and that's actually what's running the job. And there's all kinds of different ways to run this. You can run it SSH shell, which is technically different, VirtualBox, Parallels, Docker, Kubernetes, or do some kind of rolling of your own. And this is a screenshot here, and essentially you choose what you want to run based on the abilities. There are drawbacks and features for each one. For example, you're not going to have a clean environment if you're doing SSH, but you will if you are on Docker. I'm running Docker because it is the easiest based on what's currently out there and the previous examples that are there. I know some people dislike Docker. If you dislike Docker, you can do Kubernetes and figure it out yourself, or possibly something else. One second here. So what this is showing is once you've configured, and I don't want to get too deep in the weeds on the exact commands to run. I have a slide at the end that I can show on how to register these things. But essentially, what you do is you register runners, which then have the executors under them. And when you are looking, you can kind of see here on the left under the CI/CD settings, you can specify runners that you want running on your individual project. And each one can have individual tags, like this one is a ARM64 box. You can't see under it, but the one directly, no, that's an ARM, but the third one under here is AMD. So they actually can be heterogeneous, and you can even have tags inside your configuration that says, I only want to run this job on x86. It is smart enough to understand precedents, like you can only run this task after this task. All that's inside the GitLab CI YAML file. And the other thing I want to mention here is, before I mentioned it's free if you run it on your own hardware. Well, you can actually run it on other people's hardware or their hardware. If you see my pointer, if you click on this thing, which actually is enabled by default, they give you, I think, 100 hours of compute time, whatever an hour of compute time is, to run on their machines. 100 hours per month, I think it is, or something. If you're compiling anything inside Yocto OE, you eat that up on your first run. It's not even funny. And then they want you to pay them for more access to their computing powers. So these boxes right here, well, this third one is actually my desktop in my office. So it doesn't take, I mean, as long as you don't care how long it takes, it doesn't take that much computing power. Okay, so I've mentioned the GitLab CI config file. All you really need is that. And I'm highly recommending CAS. I think a lot of people are using CAS. It's a very easy way to automate building. And it'll make your life a lot easier, at least in this specific example. If you don't want to use it, it's beneficial for this example if that's the only reason you want to run it. So what is the GitLab config file? It's basically a way to run shell scripts. If you actually look at it, it's actually a YAML file that's running shell scripts. So I'm pointing here, like it's running makedir, just like you would in a shell. It's running CAS shell, just like you would in a normal shell. This CI jobs to CAS is literally a shell script. Now, one cool thing is you can reference shell scripts inside your Git tree, and it doesn't matter what language that they're in. So I think in ours we have Bash and Python, and I think Ross wrote something else in yet another third language. So there are multiple ways to skin this cat. You can even have environment variables to pass where things are. Someone on Slack was asking about download directories and state. So essentially, you can, when you launch your Docker, you can specify where the volumes are to share between them, and you can specify that you want to reference this existing state on your local disk, and then you just pass it in here as a global variable to CAS, and then CAS will actually run with it perfectly fine. And if you don't have it, so I'm running this exact same thing on my local box and then a remote ARM box that doesn't have state for various reasons. And so what it's doing here with this makedir is it's just making empty dir, and it would building like it doesn't have an state. And because it's Docker and blows away at the end of the run anyway, it's not hurting anything. It's just shoving the state into a directory that gets deleted. So it's pretty trivial. So what's CAS? So CAS is a open source tool done by Siemens. I'm sure CAS stands for something, but I don't know what it stands for. I don't know if Bruce knows what it stands for. Do you? No. So it's essentially a tool to automate the setup and running of BitBake, and it has yet another YAML file. So that's one thing I kind of liked of combining these two things, is both GitLab CI config files, a YAML file, and CAS is a YAML file. So they do dovetail pretty nicely there. And this is a YAML file for our base config. And you know, we're building Pocky because Pocky is good enough for what we're trying to do. And you can specify the URLs. And another cool thing is you can actually nest these in CAS. So you can say that you want base and then a machine specific one. So for example, the Corestone 500. So, and what that's going to do in Corestone 500, it's just a couple of lines, which I don't have in this deck, but it'll override the machine to be Corestone 500, and then it'll build with all these rest of these things. And there might be one or two other things in that file, but it's usually fairly trivial. And then Bruce will like that we're actually building for perf as one of our one of our outputs. And another nice benefit is CAS Docker. So it has a Docker image out there floating. It's in the Docker repository, but they have a superior one. A few slides ago, right here. If you see where this image is, this is actually specifying the image to run, and that way you don't have to include a generic one and then install CAS via a secondary thing, and you like with Python or whatever, or curl. So what are the benefits of developing this way? I mean, everything is very reproducible because it's a brand new Docker every single time. So unless you have some kind of internal race, you're building with absolutely nothing that's existing there already, and the very minimal tools to build the package, the binary, the image. And as I referenced a little while ago, you can use an existing state in DLDIR so that you can, not hammer your network and use existing things via passing in both of those via the Docker volumes. Again, if you want to use SSH or something like that, you can do it very similarly. You just have to clean up for yourself. So what other cool features are there in GitLab CI? So you can actually schedule runs, and it actually will email you when things fail and when things start working again. It doesn't email you saying, oh, it's still working. It'll tell you when it failed and when it works again. So here's a little snapshot in the GitLab CI/CD of the scheduled builds, right? So I mean, I kind of gave them descriptive names of nightly and weekly, and then it tells you when they run, and then you can actually even see here the check mark and the X of whether it worked or whether it failed last. And I don't have a picture of it, but a cool feature of this is it actually takes cron style descriptions. So if you wanted it to run every 15 minutes, every 4 hours, once a day, you can specify it cron style and it will do it, which probably to me means that it's actually a cron job underneath all of this. And this is what the email looks like when it fails, right? So it'll email you and say it failed. It'll tell you where it failed and give you a link to it. It's not flat text for those that like getting flat text. It is an HTML email. And one kind of nice thing, and like I realize that this is a bit of a character barf onto the screen, but essentially what you can do is actually run Docker locally, and specify right here the image, and then just a bin bash at the end if you know Docker, and it'll put you into the shell of this CAS image, and then you just kind of clone your tree and build it like you would a CAS, and you're in pretty much the exact same environment. So if you're actually trying to set this up, so this is really useful for when you're setting up a brand new project and you can't get really anything to work, and you don't want to upload something to GitLab CI and then have it blow up and then have to pull it down and then make some changes and then re-upload it. It's because I was doing that again because I am a dummy. I was doing it the hard way. And then after a week, I'm like, oh, I can just run this locally. And it definitely sped me up significantly when I ran that. And then potential problems. How am I doing on time? 20, 10 more minutes, cool.
It's
So,
just Bruce.
What's this?
The next presentation is Bruce anyway, so if you know
Oh.
the time can be flexible if you need to go. You'll just have to negotiate with him.
I think we're pretty close to the end, so I think the only problem will be is if there are actual questions. So you can't share S-state with non-container users using cast. So what does that mean? So if you have an existing S-state and you're like, okay, cool, like on your desktop, you're like, okay, cool, let me run a Docker on here. You will get user collisions of all kinds of permissions in your S-state, and then you get to chmod a S-state, which will take, on my desktop, it took about half an hour. It might take longer if you have more than, you know, half a terabyte of S-state, which I think is actually pretty small. And the same for actually DLDR. It's fun permission issues. And then it's pretty much, I think it's impossible. It might be possible, so I'll just call it difficult to access failing Docker images. And by that, essentially when it fails, it moves on to the next one on the same machine and doesn't really save anything except for some text files. So if you actually care about, like on the autobuilder, I believe it'll stay in the broken state. So you can get on it and actually debug it. And GitLab has moved on because it's got stuff to do. So improvements, at least from my perspective, based on what I'm currently running. So I have yet to find a way to get it running in tempfs, which I think would really be optimal because you don't really care about preserving much of anything that's been running in that Docker container. So it running in tempfs would really free up a lot of the IO that's happening. Run QEMU working in a non-privileged container. So I didn't have a picture of it because I don't have it working the way I want, but I do have Pocky test image for all the machines up and running, and it works, but you have to essentially run a ton control to get the networking to work. And for that, you need to have a privileged container. And everyone's like, oh, just run slurp. Well, slurp is not working for me. So I essentially, yeah, it's not significant. That's not working for me. And then a last one is an optimal number of runners on a single host. So you might have a pretty beefy, 64 core system, and it'll iterate. If you just have one on your layer, it'll iterate through very slowly, especially for an S state. But if you have 4 or 8 running on the same one, and you've carved up the CPUs to be, let's say a quarter of it each, and you have 4, then you actually can parallelize it and actually run significantly faster. Doing that for for using S state, it's about 4 times faster. It's actually pretty nice. But if you're actually building from scratch, like if there's a new GCC, you actually see a degradation in performance. So that kind of needs to be tested more and see if there actually is a sweet spot or if it's just outsmarting yourself or outsmarting myself. So thanks. If you actually want to see this, that actually should be zeros. Those are not, look like O's. Anyway, this is my personal GitLab where I've been playing around with this for a couple months now. If you want to see it and poke around, obviously, if you're not me, you don't have permissions to do much with it, but look at it. But it's there if you want to see it.